Hello students, in this video we are going to discuss the some MCQ type problems based on the topic multiple integral. Basically in this particular video we are going to discuss some MCQ type problems based on the topic of multiple integral, in which we are going to cover the problem based on the double integral, how to evaluate the double integral, how to calculate the area bounded by the curves, and change of order of integration, and then of course the problems of the volume bounded by the surfaces. So let us start with the very first problem. So in this case we are given a problem of a double integration, and we are given this is our function f of x y, and I want to integrate with respect to y and with respect to x. So I want to evaluate this integral. So in this question, if you see here we are given that the limit y varies from 0 to 1, limit x varies from 0 to 3, but sometime we are not given limit in this way. So in that case, we are going to assume that if dy is written first here, it means that the inner limit is of variable y and the outer limit is of variable x, right? And the second thing is, if you just look at here in this integral part, because the limit of integration is constant, then we can evaluate this integral like separating the variables also. Okay, I'll try to show to you how to evaluate this integral in both the ways. So like here the inner limit is dy dx. It means that firstly we need to integrate with respect to y and then with respect to x. So like the partial derivative, double integral also behave like in the same way. That means if I am integrating with respect to y, and we are treating x as a constant. So I'm taking x constant means I can take x outside. So we are going to evaluate integral y square with respect to y, and then we can integrate it with respect to x. So the integral of y square is y cubed by 3 with the limit 0 to 1 dx, using the power rule that integral of x raised to power n dx is x raised to the power n plus 1 upon n plus 1 plus c. This is the formula of the integration. So if we substitute upper limit and lower limit, then we can get here 1 by 3 is constant. It can be taken outside. So on substituting upper limit, this is 1 cube minus 0 cube dx. So 1 cube is 1, 0 cube is 0. So basically we left with 1 by 3 times 0 to 3 x dx. And again, by using the power rule, integral of x is x squared by 2 with the limit 0 to 3. So this is 1 by 3 into 2. So on up substituting upper limit, 3 square minus 0 square. So this is 9 by 6. 9 by 6 means this is 3 by 2. So what is the value of this integral? The value of this integral comes out to be 3 by 2. Okay. This is the process of evaluating the integral. Now, one more important thing, like I told you, that when both the limit of integration are constant, like you can see here, the limit of y varies from 0 to 1, x varies from 0 to 3. It means that the region is a rectangular region. So when the limit of integration is constant, means the variables, they doesn't depend upon each other, then the integral 0 to 3, 0 to 1 x y square dy dx, it can also be evaluated by separating the integral. This is 0 to 3 x dx and 0 to 1 y square dy. So if the limit of integration is constant, so we can express the double integral as a product of two single integrals. So we can solve them separately. Integral of x is x squared by 2 with the limit 0 to 3. Integral of y square is y cubed by 3 is limit 0 to 1. So here it is 3 square by 2 minus 0, and here it is 1 by 3 minus 0. So this is 9 by 2 into 1 by 3. So answer comes out to be 3 by 2. So in both the way, we can get the same answer, right? So this is the process of evaluating the integral if the limit of integration is constant. Now let us consider the another problem. So this time we need to evaluate our integral 0 to 2, 0 to x, dx, dy, right? So here it is written as 0 to x and 0 to 2. So when the inner limit is a function of y, if the inner limit is a function of x, that means that variable, that limit is for variable y only. So it means that either here it is written dx dy, but because this is a function of x, it means that this limit must be of variable y. So it means that actual representation of this integral should be 0 to x dy dx. Now, because the limit is in the variable form, so we are not able to separate the integral. So firstly, we need to integrate with respect to y, then with respect to x. So what is the integral of dy? This is y with the limit 0 to x. So on substituting upper limit and lower limit, this is x minus 0 dx. And the integral of x is x squared by 2 with the limit 0 to 2. So on substituting upper limit, that is 2 square by 2 minus 0. So 4 by 2 answer comes out to be 2 only. So the correct answer in this case is option D. So integral of dy is y because derivative and integral they are inverse of each other. So integral of dy is y. Okay. And here again I'm telling you, here it is written that the inner limit is of variable y, but sometimes it is not written in this way. Sometimes the integral is given in this particular form also. So if the limit is a variable limit, then we firstly need to understand that either firstly we need to integrate with respect to y or with respect to x. So if your inner limit is a function of x, it means that this limit is for variable y. And if your inner limit is of function y, like if we have f1x to f2x and the outer limit is constant, say a to b, it means that this limit is of variable y. So firstly we need to integrate with respect to y and then with respect to x. And if the inner limit is a function of y, say g1y to g2y, that means this limit is of variable x. So firstly, we need to integrate with respect to x, then with respect to y. Okay. Now let us move to the next question. The next question is the area bounded by the lines x equal to 0, y equal to 0, x plus y equal to 1. Now the first thing is, how do we calculate the area? Area can be calculated as double integral dx dy over the region R, or it is also equal to double integral over the region R dy dx. That means it is our choice that either firstly we need to integrate with respect to y then with respect to x, or firstly we are going to integrate with respect to x with respect to y, right? So firstly we need to understand that what kind of region we are given here and what is the limit of the variable. Okay. So in this case we are given the three curves. X equal to 0 is a line which is basically, if we draw the rough sketch of the region, this is our x-axis, this is our y-axis, and this is origin. So x-axis means this is y equal to 0, x-axis means y equal to 0, and y-axis means x equal to 0, and x plus y equal to 1. So the intercept form is when x equal to 0, x plus y equal to 1. So if x equal to 0, it implies that y equal to 1. That means here the point of intersection of this line with this line is at the point 0 comma 1, and if y equal to 0, then the value of x is 1. So it means that here it will intersect x-axis at the point 1 comma 0. So if we join them, this will gives us the line x plus y equal to 1. So this is the triangular region. This is the triangular region, and I want to find out the area bounded by this region. Now, the question is, how do we find out the limit of the variable? So, there are two ways to find out the limit of this function. The first one is, what can we do? We simply consider a small piece of rectangle, and we can move it firstly horizontally or vertically. This is our choice. Okay. For example, I firstly move horizontally. Then if I move it horizontally, then the value of x started from this line. This line is x equal to 0, and end at this line. This line is x plus y equal to 1. So basically, we are considering the limit of x because horizontally the value of x moves from left to right because x is increasing in the this particular direction. Here it is 0, 1, 2, 3, 4, 5, 6 on. So the value of x always move from left to right, and the value of y always move from bottom to top. So when we are going to calculate the limit, your inner limit is a constant, and your inner limit may be in the variable form, but outer limit is always constant. So what is the criteria to calculate the limit of the function? The limit always move from curve to curve and boundary to boundary. Okay. So because firstly we are taking the limit of x, so the value of x started from this line. This line is x equal to 0. So the limit of x started from 0 and end at this line. So what is the value of x along this line? So x is equal to 1 minus y. So the limit of x varies from 0 to 1 minus y. This is the limit of x. And to cover this whole region, we need to move this strip from y equal to 0 up to this particular point here. The value of y is 1. So the limit of y varies from 0 to 1. So this is the limit of x and y if we firstly move horizontally. So it means that what will be the area? Area is given by 0 to 1, 0 to 1 minus y dx dy. So this is equal to 0 to 1. Integral of dx is x with the limit 0 to 1 minus y dy. So this is 0 to 1. X become 1 minus y minus 0. So this is 1 minus y only. And integral of 1 minus y is integral of 1 is y. Integral of y is y square by 2 with the limit 0 to 1. So on substituting limit 1 minus 1 by 2 minus 0. So answer will be 1 by 2. Okay. So what is the correct answer? The correct answer is option A. So this is one of the way to find out the limit of x and y. Okay. So the another way is, because this is a triangular region, this is x-axis, this is y-axis, this is a region, and this is the region. X equal to 0, this is a line, y equal to 0, this is a line, x plus y equal to 1. So in this case, instead of firstly moving horizontally, if we move vertically, so this is the point 0 comma 1, and this is the point 1 comma 0. Okay. So if we move vertically, the value of y varies from curve to curve. So started from this line is y equal to 0, and end at this point. This point lies on the line x plus y equal to 1. So what is the value of y along this curve? This is 1 minus x. So the limit of y varies from 0 to 1 minus x, and the limit of x varies from boundary to boundary. So here the value of x is 0, and here the value of x is 1. So the limit of x varies from 0 to 1. So we can also calculate area by integrating 0 to 1, 0 to 1 minus x dy dx. Because if we firstly move vertically, means we are firstly going to integrate with respect to y. And why we are treating x as a constant, like I told you now, firstly I have considered a small piece of rectangle here, and I move vertically, means I fix the value of x when we are moving vertically. So that's the reason when we are integrating with respect to one of the variable, we are treating other variable as a constant during that time. Okay, so if I solve this integral, integral of dy is y. So this is 0 to 1, 1 minus x dx. So integral of 1 is x, integral of x is x squared by 2 with the limit 0 to 1. So this is 1 minus 1 by 2, answer is again 1 by 2 only. So you can get the same answer. Okay, and this is how we can calculate the limit of the function and we can calculate the area. Otherwise, if you just look at here, this is a triangular region. This is a triangular region where the point of intersection on x-axis is 1, 0. The point of intersection on y-axis is 0, 1. Means the height is 1 unit, the length is also 1 unit. And what is the area of a triangle? Because the region is a triangular region. Area is half base into altitude. So base is 1 unit, altitude is 1 unit. So 1 by 2 into 1 into 1. So answer is 1 by 2. So with the help of the direct area formula also, we can get the area and the answer is 1 by 2. Okay. So we can use any one of the method to find out the area of this region. Okay. Now let us move to the next question. Okay, the next question is to find the area bounded between y square equal to 4x and x square equal to 4y. Which of the following is correct? Okay, so if you just look at here, in all the integral, we are given inner limit as a function of y and outer limit is a function of x. Okay, firstly, we are going to draw the rough sketch of the region. This is our x-axis, this is our y-axis, this is the origin. So we are given y square equal to 4x and x square equal to 4y. So when we are given the two region, the first step is we simply try to find out the point of intersection of the two curve. Okay. So what is the value of x from here? It is y square upon 4. If I substitute the value here, then this is y square upon 4 whole square equal to 4y. So it will gives us y power 4 upon 16 equal to 4y or y power 4 equal to 64y. So if we solve this, y common, y cube minus 64 equal to 0, it means either y is 0 or y equal to 4. Like I already told you that a cube minus b cube equal to 0, having only one real root, that is a equal to b. So it means that the two curves intersect at the point y equal to 0 and y equal to 4. And if y equal to 0, the value of x will be 0 and x is also equal to 4 square by 4, that is 4. So therefore the point of intersections are, what will be the point of intersection of the two curves? The point of the intersection are 0, 0 and 4, 4. Okay. Now the next step is we need to draw the rough sketch of the region. So firstly, I am considering y square equal to 4x. So y square equal to 4x means x equal to y square by 4. So because x is equal to y square, we know that square of a number is always positive. Okay. And y square equal to 4x means y can be negative. Y can be negative. Negative y is this side and y is positive this side. So I can choose the negative value of y or positive value of y, but the corresponding value of x is always positive. Okay. So x is positive in this direction. So it means that it has a shape of the curve is like right hand parabola. Okay, because I can choose the value of y to be negative or positive, but the value of x is always positive and curve is symmetric because minus 1 square is 1, 1 square is 1, minus 2 square is 4, and 2 square is also 4. So the curve is symmetric. Similarly, if I consider x square equal to 4y, it means y is positive. It means that the region is in the upward direction only, so it is a upward parabola. So it is like this. So it means that already we have calculated the point of intersection. It is 0, 0 and 4, 4. So basically this is the region of integration, the intersection of the two parabola. Now the next step is we need to find out the limit of x and y. But if you just look at all these options, we are given the inner limit as a function of x. Means we need to move vertically because we need to find out the limit of y. Okay, so this is a right hand parabola. The equation of right hand parabola is y square equal to 4x, and upward parabola, its limit is x square equal to 4y. So if we move vertically, the value of y started from upward parabola and end at downward right hand parabola. Okay, I told you the value of a first variable moved from curve to curve. So the value of y started from upward parabola, that is x square by 4, and end at right hand parabola. And because the entire region lies in a first quadrant, common region lies in a first quadrant, so it means y is positive. So y equal to square root of x, 2 times square root of x. So the limit of y varies from x square by 4 to 2 times square root of x, and the limit of x varies from boundary to boundary. So started from 0 and at 4. So the limit of x varies from 0 to 4. So what is the representation of area? So area is given by double integral over the region r dx dy, or because I firstly move vertically, so I can write dy dx, where the limit of y varies from x square by 4 to 2 times square root of x, and the limit of x varies from 0 to 4. X square by 4 to 2 times square root of x, 0 to 1. Not correct option. 0 to 4a. A is not there, so this is not the correct option. X square by 4a, because a is not there, so definitely this is not the correct option. So the correct answer is option D only. So in this case, the correct answer is option D, because the limit of y varies from upward parabola, that is x square by 4, to the right hand parabola y is equal to 2 times square root of x, curve to curve, and the boundary to boundary means 0 to 4. This is the limit of x. Okay, so this is the representation of this particular area problem in the form of a double integral. Okay, now let us move to the next question. Now the question is, this time we are going to change the order of integration. Okay, so what we are given? We are given that integral 0 to 1 and integral 1 to e power x dy dx. So even you can see here, inner limit is a function of x. So it means this limit is a variable y. So what is the lower limit of y? It is 1. Upper limit of y, e power x. Lower limit of x is 0. And the upper limit of x is 1. So the first step is, I'm going to draw the rough sketch of the region. So this is our x-axis, this is our y-axis, this is our region. So x varies from 0 to 1. This is x equal to 0 means y-axis, x equal to 1 is the line parallel to y-axis, y equal to 1 is the line parallel to x-axis. So this is y equal to 0, this is y equal to 1. And y equal to e power x means straight line. Straight line passes through origin, because when x equal to 0, the value is the value is 1, 1 to e. So it means that the value of y varies from 1 to e, y 1 to e. e raised to power x is basically a monotonically increasing function, right? Its value is 0 when x tends to minus infinity, otherwise it is an increasing function. So this is a line x equal to 1 and this is the curve. So if we just look at here, the limit of y varies from 1 to e power x. Y varies from 1 to y equal to e power x, and the value of x varies from 0 to 1. So it means that this is the region of integration here. This is the region of integration. Now I want to change the order of integration. Change of order of integration is now instead of vertically, firstly we move horizontally. Horizontally means the value of x is started from the curve and end at this line. So this line is x equal to 1. And what is this particular equation? Y equal to e power x. So what is the value of x? It is log of y. Okay, so what is the limit of x? X moved from curve to curve, because when I move horizontally, the value of x started from the curve and at this line. The value of x started from log of y and end at 1. And the limit of, because the point of intersection of the two curve is, this is a line e power x and this is a line x equal to 1. So the point of intersection is 1 comma e. So what is the limit of y? Y varies from 1 to e. Okay, the value of y started from 1 to e, boundary to boundary. Okay, so the limit of x varies from log y to 1 and the limit of y varies from 1 to e. So what is the representation of area? Integral 1 to e integral log of y to 1 dx dy. So 0 to 1, no. 0 to e and log of y to 1, no. E to 1, 1 to log y, again not. So it means that the correct answer is option D, because the value of e is greater than 1. Okay, and we are moving from bottom to top while calculating the limit of the function. So this is the representation of this integral after changing the order of integration. Okay, let me tell you again. So the curve is like this. So this is a line y equal to 1. This is a line x equal to 1. And this is the curve y equal to e power x. So the intersection of the line, because when x equal to 1, y equal to e raised to the power x. So it means y equal to e power 1. So the point of intersection is 1 comma e, and here this is y equal to 1, and this is the point 1 comma 0, because this is a line x equal to 0. Okay, so if we move horizontally, the limit of x started from this curve, that is this line, to this line. Here the value of x is log of y, and here the value of x is 1, and the limit of y varies from 1 to y equal to e. Okay, so this is the representation of the integral. Okay, now let us move to the next question. Okay, the next question is, we want to evaluate the integral 0 to infinity x to infinity e raised to power minus y upon y dy dx. Okay, so now if you just look at this integral, this is 0 to infinity x to infinity e raised to the power minus y, and here it is y raised to the power minus 1 dy dx. So in this case, because the value of y is minus 1, so if I try to evaluate this integral even after applying the product rule, it is not possible to evaluate the integral directly. So what can we do? If I change the order of integration, that means if I integrate firstly with respect to x, then this whole function is treated as constant. Okay. So in this case, to evaluate this integral, firstly we need to change the order of integration. So we are given the inner limit is a function of x. So it means that this limit is a variable y. So the limit of y varies from x to infinity. The limit of x varies from 0 to infinity. So because I want to change the order of integration, so firstly we need to draw the rough sketch of the region. So this is y equal to 0. So the curves are y equal to x and y equal to infinity. Y equal to infinity means the end of the first quadrant. Y equal to x is a straight line passes through a region. The point of intersection is infinity, infinity, right? And the limit of x varies from 0 to infinity. So this is the region. The value of y started from x to infinity, and the limit of x varies from 0 to infinity. Curve to curve, curve to curve, boundary to boundary, 0 to infinity. Now, if I change the order of integration, means we move horizontally. Horizontally, the value of x varies from curve to curve. Now, the value of x started from this line. This line is x equal to 0 and end at this line, this line. So, along this line, the value of x is y. So, the limit of x varies from 0 to y, and the limit of y varies from again boundary to boundary, that is 0 to infinity. So, if we change the order of integration, then this integral is written as 0 to infinity, 0 to y, e raised to power minus y upon y. Now dx dy, because I have changed the order of integration. So if we integrate with respect to x first, then this whole function is constant, right? If this whole function is constant, this can be written as 0 to infinity e raised to the power minus y upon y. And integral of dx is y with the limit 0 to y dx dy. So this is 0 to infinity e raised to power minus y upon y. And here, this is y minus 0, that is y. So 1 power of y, this get cancelled out with this. So now the integral of e power ax is e power ax upon a, of course, plus some arbitrary constant. So its integral is e power minus y upon minus 1 with the limit 0 to infinity. So minus limit y tends to infinity e raised to minus 5 minus e power 0. So its value comes out to when it tends to infinity. So it is e power minus 5 means 1 upon e power y. So when limit y tends to infinity means limit y tends to infinity. So this is 1 upon e power infinity tends to 0. So the upper limit is 0 and lower limit is 1. So minus of minus become plus 1. So the correct answer is option A. Okay. So sometime it is not easy to evaluate the integral directly. So in case of the double integral problem, firstly we need to change the order of integration. When we change the order of integration, that means if we integrate firstly with respect to x, then function of y is treated as constant. So in this case, now this whole function is constant. Integral of dx is y. Sorry, dx is x. Substituting upper limit and lower limit, you can get the answer easily. Let us try the another question. So the question is, we want to express this integral into polar coordinate system. Okay, so firstly we need to see that what is the region. So here the region is 0, x-axis, y-axis, the limit of x 0 to infinity, x equal to 0, x equal to infinity means boundary of the first quadrant, y equal to 0 to y equal to infinity, it means the entire first quadrant. Okay, so when we change it into polar form means we put x equal to r cos theta and y equal to r sin theta. Means we are considering one circle whose center is origin and radius is r. So in this case, we are considering any point in this particular quadrant, say xy, And so we are assuming that this angle is theta and this distance is r. So you can see here the value of r started from here because I want to cover this entire area of this region. So the limit of r varies from 0 to the boundary of this particular region because the region boundary is infinite. So the limit of r varies from 0 to infinity, and to cover this whole region we need to rotate this line from 0. The value of theta varies from 0 to pi because it will cover only first quadrant. So the limit of theta varies from 0 to pi by 2. So what will be the representation of the integral 0 to infinity 0 to infinity e power x k plus pi square dx dy? Basically it should be negative sign, but anyhow because I need to represent it. So this is equal to integral 0 to pi by 2 0 to infinity e raised to the power r square. But what about dx dy? When we transform xy into r theta, then dx dy will be transformed to Jacobian of transformation time dr d theta. And what is Jacobian of transformation? This is Jacobian of xy with respect to r theta. That is curly x upon curly r, curly x upon curly theta, curly y upon curly y upon curly r, curly y upon curly theta. So this is derivative of x with respect to r is cos theta. Derivative of x with respect to theta is minus r sin theta. Derivative of y with respect to r is cos theta. Derivative of y with respect to theta is r y with respect to r is r sin theta. So here it is sin theta. This is sin theta and this is r time cos theta. So if we solve this, this is r time cos square theta plus r times sin square theta. So its value comes out to be r. So what is the representation of this integral? E raised to power square. So dx dy become r dr d theta. So it is e raised to the power 0 to pi by 2, 0 to infinity e raised to power r into r dr d theta. So it means the correct answer is option B only. R varies from 0 to 1 not possible because the region is the entire first quadrant, and 0 to infinity 0 to pi not possible because here it is only dr d theta. But dx dy in case of polar coordinate system its value is r dr d theta. We need to remember this particular property and hence we can get the answer. Okay, now let us move to the next question. The next question is we want to find out the point of intersection of the two curves. Okay, so y equal to x square. Y equal to x square means x can be negative, x can be positive, but y is square. It means that it is a upward parabola. Y can be x can be negative, x can be positive, but y is always positive. This side y, this side x. But y equal to 4 minus x square means y equal to 4 minus x square means I can firstly imagine y equal to minus of x square. Y equal to minus of x square means it is a downward parabola. But 4 minus x square means we shift the origin from 0 to 4. So it means that it is the downward parabola. It is the downward parabola like this. Okay, so this is the region of integration. But we are interested to find out the point of intersection. That means where the two curves intersect each other. So point of intersection y equal to x square and y equal to 4 minus x square means replacing y equal to x square equal to 4 minus x square means to x square equal to 4. So x square equal to 2. So the value of x comes out to be plus minus root 2. If x equal to plus minus root 2, y equal to 2. Y is positive. So the point of intersection is a symmetric point. One point lies on the left hand side, other point lies on the right hand side. So its value is minus root 2, 2, and this is root 2, 2. So it means that the correct answer is option A only. Okay, now let us consider the next problem. The next question is, again, the problem is based on the change of order of integration, and we are given limit as 0 to 1 to y to 2 e power x square dx. So in this case, because inner limit is a function of y, so this limit is a variable x only. So the limit of x varies from 2y to 2, and the limit of y varies from 0 to 1. So because I want to change the order of integration, firstly we need to draw the rough sketch of the region. So this is our x-axis, this is our y-axis, and this is our origin. So x equal to 2y or y equal to 2x. It means that a straight line passes through region, but it is tilted bit this side because the equation is y equal to x by 2. So this is the line y equal to x by 2. Another one is x equal to 2. X equal to 2 is a straight line parallel to y-axis. So it means that at what point they intersect, because x equal to 2, if x is 2, the value of y is 1. So this is y equal to 0, and this is already given as y equal to x. So what are the point of intersection? One is 0, 0. So now if we see the limit of x, because x is given in the variable form, so the limit of x started from the line and at the line, this one, x is equal to 2y. X is equal to 2y to x equal to 1. Sorry, x equal to 2. The value of y varies from 0 to 1. This is the limit of integration we are given. So on changing the order of integration means, instead of moving vertically first, we need to move we need to move we need to move vertically first. Vertically means the value of y started from x-axis and end at the line. So along x-axis the limit of y is 0, and along this line the limit of y is x by 2, and the limit of x varies from boundary to boundary. So it started from a region and end at this particular line. So the limit of x varies from 0 to 2. So what is the representation here? 0 to 1, 2y to 2, e raised to the power x square. So it should be dx dy. So dx dy, this is equal to integral 0 to 2, 0 to x by 2, e raised to the power x square dy dx. So 0 to x by 2, 0 to 2. So here we have a two integral with the same limit, but here e power x square, which is already present in the function, but here it is not. So this is not the correct option. This is not the correct option. This is also not the correct option. The correct option is option B only. Okay, now let us move to the next question. The next part is again we want to evaluate this integral 0 to 1, 0 to x square x time e raised to the power y dy dx. Now inner limit is a function of x. So it means that this limit is of variable y. And if we integrate with respect to y, then x is treated as constant. So 0 to 1 x is common. And integral of e power y is e power y. So it is e power y with the limit 0 to x square dx. So answer is 0 to 1 e power x square minus 1 dx. Now, if I separating the integral, then this is 0 to 1 x into e power x square dx minus integral 0 to 1 dx. So, in the first integral, it is like a composition of the function, and beside this, we have a function. So, when we have a composition of the function, say f of g of x, then we are expecting the derivative of the function should be present beside this. So if it is so, then the value of this integral is integral of this function, say it is capital F times gx, where capital Fx is the integral of small fx. Okay. So what can we do? Either I can substitute x square, the derivative of x square is 2x. So multiply and divide by 2. Okay. So it means that if I put here, put x square equal to t, then 2x dx is equal to dt. So it is like integral 2x e power x square dx is equal to integral e raised to power t dt. So its integral is e raised to power t plus c. So if you substitute here, this is 1 by 2 times e raised to power x square with the limit 0 to 1. And here the integral of dx is x with the limit 0 to 1. So I'm substituting the limit e minus 1 minus 1. So 1 by 2 e minus 1 by 2 minus 1 is minus 3 by 2. So the answer will be e minus 3 by 2. So is there any calculation mistake here? Let me check. X as it is. Its integral is e power y is e power y. Substituting upper limit e power x square. Lower limit e power 0. E power 0 is 1. So is multiply and divide by 2. Its integral is e raised to power x. So it is e power x square minus 1. The limit is 1 by 2 only. So answer is here e power x square. The limit 0 to 1. Okay. So it means that there may be some calculation mistake here. So answer which should be e minus 3 by 2. Okay. Let us come to the next question. The next question is again the problem is based on the change of order of integration, but this time they are expecting only what is the limit of variable x, that is the inner limit. In this case we are given inner limit is a function of x, so it means that this is of limit y. Limit of y varies from x square upon 4a to 2x, and the limit of x varies from 0 to 8a. So if I want to change the order of integration, firstly we need to draw the rough sketch of the region. Okay, so the limit of y started from y equal to x square upon 4a and y equal to 4 2x. So x square means x can be negative, x can be positive, but y is always positive. It means it is an upward parabola, symmetric curve, and y equal to 2x is a line passes through this region. So we are given limit of y, it means that we are moving horizontally. The limit of y varies from upward parabola, that is the limit of y varies from x square upon 4a to 2x, and the limit of x varies from 0 to 8a. So firstly we need to find out the point of intersection. So x square upon 4a equal to 2x. So x square equal to 8ax. So x common, x minus 8a equal to 0. So the value of x is 0 and 8. So the point of intersection is 0, 0 and 0, comma 8a. Okay. But now I want to change the order of integration. Change of order of integration means instead of horizontal, now we move vertical first. The limit of x started from the line. The limit of x started from the line x equal to 2, y equal to 2x means x equal to y by 2. And the limit of y depend upon the parabola. So the value of x is equal to 2 times square root of ay, because the first quadrant they are positive. So x square equal to 4ay. So x equal to 2 times square root of ay. 2 times square root of ay. So the limit of x varies from y by 2 to square root of 2ay. Square root of 2ay means square root of 4ay. So the correct answer is option A. Okay, now let us consider the next one. Again, the problem is based on the change of order of integration. So inner limit is the function of x. It means the limit of y varies from 0 to x square by 2, and the limit of x varies from 0 to 2. So if I want to change the order of integration, firstly we need to draw the rough sketch of the region. This is x-axis, this is y-axis, and this is the origin. So y equal to 0, this is y equal to 0, and y equal to x square means upward parabola. 0 to upward parabola, and the value of x varies from 0. This is x equal to 0, that is y-axis, and x equal to 2 means a line parallel to y-axis. So this is the region of integration. Okay, so you can see here from curve to curve, boundary to boundary. So 0, 0, x equal to 2. So what is the point of intersection? So y equal to x square by 2 and x equal to 2. So y equal to 2. So the point of intersection is 2, comma 2. So now when we change the order of integration, so instead of vertically, we move horizontally. So the value of x started from parabola, that is x equal to root 2y, and end at x equal to 2. So root 2y to 2, and the value of y varies from 0 to 2. So root 2y to 2, and the limit of y varies from 0 to 2. So all the given options are incorrect. So the correct answer is none of this, because the representation is 0 to 2, root 2y to 2, f of xy dx dy. So this is the answer of this particular problem. Okay. Okay, now let us move to the next question. Okay, in this question, we want to represent this particular integral in polar form. So to convert it into polar form, the first step is we want to know that what kind of the given region is. So in this case, again, inner limit is a function of y, so it means that this limit is a variable x. The limit of x varies from minus square root of 1 minus pi square to square root of 1 minus pi square, and the limit of y varies from minus 1 to 1. So it means that x equal to plus minus square root of 1 minus pi square. So squaring x square equal to 1 minus pi square. So x square plus pi square equal to 1. This is the circle. So basically the region is a circle whose center is the origin and radius is 1. 1 comma 0. This vertex point is 0 comma 1. This vertex point is minus 1 comma 0. This vertex point is 0 comma minus 1. So we are given the limit of x varies from circle to circle and boundary to boundary. So the region is a complete circle. So if the region is a circle and we want to convert it into polar form, so what is the meaning of a polar form? Means I can consider any point on the boundary of this circle. So this point is xy. If we join this point with the origin, right, and we are assuming this distance as r and this angle as a theta, and we draw perpendicular from here, and this is basically it is like this is r, this is theta, this is x, and this is y, right? So x is the base, r is the hypotenuse. So x upon r is equal to cos theta. Base upon hypotenuse is cos theta. So what is x? R cos theta. And perpendicular upon hypotenuse is sine theta. What is the value of y? R sine theta. So x equal to r cos theta, y equal to r sine theta. So what about x square plus y square equal to r square? So in case of circle, the limit of r varies from starting from origin. That means how do we construct a circle? Basically, we start from the origin and we move a distance r started from here to the boundary of the circle. So the boundary of circle is, say, the radius is a. So the limit of r varies from 0 to a. And then we rotate this line from x-axis, and to complete this circle we need to rotate this angle theta from 0 to 2 pi. And in one of the problem we have already discussed that in case of circle, dx and dy in case of polar form, it is equal to Jacobian of transformation time dr d theta, and Jacobian of transformation is r. Okay, so if we substitute all this value in this integral, then the limit of theta varies from 0 to 2 pi, because to construct this circle we need to make the whole rotation of angle theta, and the limit of r varies from, because here x square plus y square equal to 1 and x square plus y square equal to r square. So r square is equal to 1. So it means that r equal to 1. So the limit of r varies from 0 to 1. So dx dy become r dr d theta. So what is the integral? 0 to 2 pi, 0 to 1, r dr d theta. So this is how we can convert the double integral problem into the polar form. Okay, so we'll continue this particular part in next video, because otherwise this video will extend more than an hour. So I'll continue the problem based on the multiple integral part in the next video. Okay, thank you. Have a nice day.